fact, but we're trying to do every example, so we'll talk about it. And I could have just said this, but if a line has a slope of 3/2, any line having a slope of negative 2/3 is perpendicular to it. How can we prove that? Can we prove that? I've never thought about that, but let's see. So let's do this. We actually don't want graph paper. If we're going to prove that, we want to get rid of the graph paper. So let's make a paper blank. Because here's what we're going to do. We're going to... Alright, I'm going to do this in depth, probably far more in depth than it needs to do. So let's do this. We're going to have this point here. That's going to be the point A, comma B. And then we're going to have this point here. So let's see. The slope is A over B. The slope of our line is A over B. And which means the coordinate... Hold on. No, the slope can't be A over B. The slope has to be C over D. Because our starting point was A over B. So that means that this coordinate here is A plus D, comma B plus C. Because see, it went up by the C amount over by the D amount. So that's legit. And we could draw that line. But then what I wanted to do was I want to just draw another point. Let's see. We could just draw another point. We don't know that that's a 90-degree angle. I'm going to say what we do know is using the other slope, negative D over C. So I'm going to say we're just going to create this new slope that's negative D over C. And we're going to use that to draw a new point. So what is that new point? That new point is A... But let's see, we went up C, so A plus, oh no, we went over C, so A plus C, and then we went down D, so B minus D. And what I want to show is that this is a right angle. And so I want to do that by showing that that's a right triangle. And to show that, wow, this is going to be tough. I have to show, so I need to use a whole bunch of distance formulas. I guess that's not too bad. Because I need to get that distance and that distance and that distance and show that it applies for the Pythagorean theorem. Because if it applies for the Pythagorean theorem, then that means that that will be a right angle. Okay. I think this is going to be a fair proof, so we can do that. So we got the distance between those 2 points. So we're going to do A plus C minus A, because that's the difference in the x values, plus B minus D minus B, because that's the difference in the y values, and the square root of all of that. So that's that distance. But then we're going to have plus the green distance. Well, plus we're going to square it anyway when we put it in the equation. Well, let's all just get the distances first. So we have that first distance. We have the next distance is the square root of A plus D minus A plus B plus C minus B. Okay, so that's that distance, squared. And then what is the last distance? The last distance is going to be the harder one to calculate slightly. So it's going to be A plus D minus A minus C when we distribute the negative, squared, plus B plus C minus B but then plus D when you distribute the negative. Interesting. Okay. So now what do we have to show? We have to show that that first distance squared, so this squared plus this squared equals this squared is what we have to show. So we're going to square them. We're going to simplify a lot here. So we're going to square them. So we're going to get rid of the square roots anyway. And we have a minus a. So that's going to be c squared plus, and then b minus b. So that's just going to be d squared. And then in the next one, the a's cancel. So you have plus another d squared. And then the b's cancel again. So plus another c squared. And that needs to equal all of this. So this is going to be more, I think I need to calculate out. So here the a's cancel. So this is d plus c squared. And here the b's cancel. So this is c plus d squared. Okay. And you know what? These combine over here, but I almost don't even want to do that, because what is going to end up happening here? We're going to have d squared plus 2dc plus c squared, and then plus c squared plus, or wait, we messed up, because this is supposed to be d minus c. That's critical, because what happens then is that that's negative 2dc, and then when we do this over here, this is positive 2dc. So these dc's cancel out, and so c, they do equal each other. We end up with c squared plus c squared equals d squared plus d squared. So, therefore, since we found the distance between those 3 points, and they worked for Pythagorean theorem, that means that this is a right triangle, which means that is a right angle. So therefore, if you want two lines to have a right angle, their slopes must look like this. If one slope is c over d, the other slope is negative d over c. That's what we just proved. And so their statement right here, if one slope is 3 over 2, the other slope is negative 2 over 3, is legit. And we just proved that it's true.